Hi, nice to meet you again. In this video, we will introduce how we have built a programmable system that enables our drawing software and coding software to do the automatic scale up or scale down of our shoe structures. So this is a part of our replaceable shoe structure introduction. In our previous introduction, we have introduced the innovation and the structure of our replaceable shoe parts. Especially, we have animation and Google Slide for introducing the sole and the upper. So today we will introduce the how we can use our programming building, implementation, etc. to integrate the AutoCAD Fusion 360 with the Python, that we can realize an automatic scale up or scale down programming system for our Midsole that is derived from the last. So let's see how we can realize this. So in the beginning, when we start to design a shoe, we must have a list that we have buy or granted from experienced craft or standard shoe sources, in which they can provide a shoe list like this. When we have a standard shoe list such as this one, it is in standard list width, and the length is 28 centimeters of the shoe length. And when we have this model, we can then develop our midsole further. So when we have this model, the standard list available, then we also have the three-dimension drawing data in our hands, so we can process in our further drawing or programming. So in this case, this is a standard 28 width length list. So the first step is that we need to parse, that is separate the original object, that is this list, into two parts, that is the upper and the lower part, such as this we have processed. In this process, we have split the whole list into two portions. And what we need to use is the lower portion here. Okay. Since we need this portion to develop further of our practically used list, and further to develop our midsole structure. So let's see what we have derived from the original list into our practical used list. Here is our practical used list. Okay, so the practical used list is for our further development of the practical midsole, such as this. This is our practical midsole that is derived from our practical designed list. The Midsole is used to contain the practical list with some isolate or some space for the cross or padding to be installed. Okay, so our step is as a description a step here. Our first step is that we acquired or we get a standard list and we produce the new list that is derived with uniform scale up or scale down from the standard list. Okay, so this is the first step of our derivation. And the second step is that when we have derived our new list, and then we will derive from the uniform the scaled new list. That is when we can arbitrarily scale up our 28 centimeter foot length list, standard list, to, for example, to 33 or 25 foot length standard list. So when we get a new standard new list from the standard new list from which is offered from the shoe standard list provider. So when we get the new list, such as foot length for 33 centimeter, then we can further to set up some scale up parameters so that we can derive our target shoe list. The target shoe list is a practically used list for our building or our integration or working with the crosses or other working on the shoe upper. Okay, so this is the production or the derivation of the target shoe list for practically manufacturing usage. And finally, the third step is to produce our midsole structure. That is derived or refers to the target shoe list. Since we need the size and the figure or shape information from the target shoe list, then we can derive our midsole shape and size from it. So this is the three steps that we have implemented and we have set up in our drawing programming steps. So let's see how we realize this. So this is the practically used list, and this is the midsole that is derived from it. Okay, so let's see how we can realize this. The first, our fundamental measure is that we set up some control point around our insole level. This is our control point. For example, around the peripheral of the insole outline, we have 8 control points, and in one side, and the other 8 is in other side, and have plus 1 control point in the rear end and the front end, so that we can set the size or dimension to expand or to shrink for our scale up steps. For example, we can set the front point to shrink or to expand. For example, 2 millimeter or 5 millimeter or others. Or we can set some millimeter in each of these control points, so that our program and our coding can calculate and work and or according to this control point size parameters. So let's see, since our drawing software is the Autodesk series, that is the Fusion 360, and we need the Python programming language, so that we can call the application programming interface, that is the API of the Fusion 360, the API of the drawing software. Yeah. So our step, our process is, the first we need to set up the new foot length that we want to build from the standard list. Since the standard list, the foot length is 280 about, and but our new foot length is target at 330 millimeters, that is 33 centimeters. So we just change to this figure, and we call our function to do uniform scaling up from the standard list. And after this step, our software will cooperate with the drawing software and call the software to do all the steps and then all the command and drawing ways and the method to build our new standard list. Okay, but since this is a standard, this is our standard list, that is 28 centimeter. Yeah, but if we set also 28 centimeters in for our uniform scale up process, then we still get a new list, the same as the previous one. Okay, this is our case, and then we need to go to the next step. That is, we need to based on the new standard list, we needed to build our practically used list. That is, we will build our target shoe list that will be practically used in our manufacturing and sampling building process. So again, this time we need to, and we can set up the scale up, or that is the widen or the shrinking of each control point. So in these two lines, one is for the upper area of the list, and one is for the bottom area, and we have totally 18 control point for the left side and the other side. Okay, this is the other side, and so we can control the scale up for each control point, and so this will generally, most cases the widening. For example, we can widening from the standard list at some control point to some millimeter, for example. So we in this step we get our we will produce our target shoe list. That is the list is really being used in our sampling shoe sampling production or our manufacturing lines. Okay, so this is the second step in our programming system. So after we call this scaling up function, it will execute according to this shrinking or expanding control point parameter in millimeter. This is in centimeter. Okay, so this is the second step. And when we have finished this step, we will get our practically used list, and we can send our list 3D information files to do three-dimension printing or to CNC machining, so that we can get our practical use list for our target usage. Okay, so when we have the 3D information of the practically used list, we can further to derive or to produce our midsole structure. Since our midsole need to have a reference to the practically used list. In this similar process, since as you know, our midsole must be large, somewhat larger, so that it can contain all of our practically used list inside inside it. So but the size is needed to be accurate, since in our in the midsole, the size of midsole need to be produced so that we have the space to contain the cross, that is the cross of our upper, our upper, and then the padding space of our upper, so that we can make up our midsole seamlessly and exactly match with our upper material and together with our practically used list. So we still need some control point when we derive or develop our midsole size and the figures and the shapes. So we still need, and we can still need set up the distance of the midsole inner outline to the distance of the outer surface of the list at each control point here, and at different size, and also at different levels, two levels. One is top, upper, one is the bottom. And besides this control point, we still need another two control points. One is for the insole button, or is the button thickness. So as we can see, the midsole is much have a thickness than so we need the thickness information. So this is the thickness information, and in the front end, the thickness is nearly minimized, and in the rear end, the thickness is maximized. So our shoes can exhibit this forward inclined features or characteristics. So the thickness information is put in from our thickness, rear thickness figures and front thickness figures, and In the upper level, we also can set the distance or thickness information for our upper outline of our midsole. That is relative the upper outline of our practically used list. So this is our parameters or control information for the size when reference to the practical list. Okay, so this is our setup information that we need to provide to our software design. And after this information have been provided, we can call the scaling up function as well. And after about 2 or 3 minutes, our software will accordingly to produce our new list and our new midsole according to our target size information. So we will now try to practically run once for the new length is 330 millimeter. That is 33 centimeter. So let's run and have a real understanding. Well, now it have finished and process. Okay, let's see the result of the scale up. You can see that this is our previous practical list. That is for 28 centimeters foot length, and this is our new practically used list that is derived from standard list. You can see these two lists have a significant size difference here, and this is our midsole derived from the new practically list. Okay, so you can see it is also much larger than the 28 foot length version. Okay, and we can also see that the new midsole in the new midsole, the size and the space is exactly or very precise produced to contain the padding or the closest thickness for our installing of our upper. Yeah, so this is the two different size of the midsole or the list that we can produce using different control parameters in our automatically programmable design of our list and midsole models for practical use. So this is our automatic programming system for scale up or scale down of our list and midsole. And thank you, and I hope it's very helpful for your understanding, and welcome for your comments and suggestion and cooperation. Thank you very much.